Hi, this is a supplementary math lesson for Algebra 1 on 85C. Another one, I wanted to reiterate some things going on with the equation of a line. We want to focus on the slope. That generally is the area of the equation that gives most students problems at first, so we're going to analyze that. So right now, let's say we're given this graph. Disregard this stuff for right now. This line here, we want to determine the equation of that line, okay? And I drew some points here that we know those are 2 points where the line goes through, okay? It goes through here -2 on the y-axis, and it crosses at -3 on the x-axis. Now, we said B represents the intercept. It's easy to determine what that is on the graph. It's where it crosses, where it intercepts the y-axis. Already said that happened at -2, okay? So up here, we go ahead and replace that B with a -2 as the first part of our equation of the line. Now the second part was determining the slope, okay? We said that represents the rise over the run. Okay, well, the rise, how much it rises up and down. The run, how much it runs horizontally. Okay, we run on the track horizontally. We don't run up and down. Okay, we rise in an elevator up and down. We don't rise horizontally. So which one, that's generally, which one goes on top, which on the bottom. I know rise and run is involved. What is it? Is it rise divided by run, or run divided by rise? Well, just remember, rise is higher, okay? An elevator rises, it's higher than a person running. That goes on top, okay? Running is on the horizontal, so lower goes on the bottom. Rise over run, okay? We said we set up a reference kind of triangle based on those points, okay? And we read lines the same way we read English, from left to right. So we're going to start over here at this left point. Okay, well, which one do I apply first? The rise or the run? It doesn't matter. The only thing you have to remember is we apply the minus or positive sign to the slope to the rise only. To the run, we don't. The run is always to the right because we're reading from left to right. So if there's a positive or negative involved with that slope, we apply that to the rise, to the numerator, okay? So if you keep that in mind, you'll keep out of trouble. So which reference triangle do we use? I can draw 2 of them, one on the top or one on the bottom. It doesn't matter, okay? What matters is keeping track of the rise and the run, okay? Let's use our top reference triangle and apply the number 3 first. What is it? We're going from left to right, 3 units to the right. That is the run. It's the horizontal component. That goes on the bottom. Okay? Then what are we doing? Then we drop 2 units. -2 is the rise. -2. Let's use our bottom reference triangle. If we used that, we drew a triangle, okay? Starting from left to right. We're always read from left to right. What are we doing? We are dropping 2 units. Okay, what is that? That is the rise. What is the rise? -2 units. Okay? Why do I have a minus sign on my reference triangles? Because we're going down. Here we started left, we came to this point, and then we dropped down. Here we started at this point because we're reading from left to right. We dropped down, and then 3 units to the right. Okay, so we drop down, is our -2 is our rise. Our run then is 3 to the right. 3. Notice our denominator is always a positive number. If the slope is negative, okay, in this case, we get the same number, -2/3. That is the slope of our line. So we go up here and replace M with -2/3. Okay, that is the equation of our line. Y equals minus 2/3 x minus 2. Okay, that represents the equation of this line right here. Okay, no matter which way we selected for our triangle, the only thing to keep in mind, we read from left to right, always start to the left, and we apply the sign to the numerator, the drop in rise or the actual rise in rise. Okay, and we said, what is that according to the right hand rule? Okay, we look at the origin of our graph, okay, and I take my right hand straight out, and then I approximate the shape of this line with it. Okay, my hand is pointing downward to the earth, not to the sky, therefore it is a negative slope. Okay, our equation has a negative slope in it. It's minus 2/3, okay, x. 2/3 is the slope, okay? So that's for this particular line here, okay? Now I want to look at what do we have going on when we have different slopes, okay? So I'm just going to erase this stuff for now, just to kind of unclutter my board, okay? And what do I have going on? Okay, so here I have a slope of a equation of a line 4x plus 1. I know the y-intercept is 1, and I notice all of these y-intercepts are 1. I made that the case just so we can compare them and see what's going on here with the slope. So I apply then from that point a slope of 4, which means what? Well, gee, 4 is an integer, okay? It's not expressed as a fraction. It's not expressed as a rise over a run. How do I get 4 equal to a rise over a run? Okay, well, we do that by recognizing any integer can be expressed as a fraction itself divided by 1. Okay, that will be what the slope we use to apply that. And I didn't particularly mention that in our first lesson, but I just want to see. So when we have whole integers, okay, we actually still do have a slope. Okay, it's that integer over 1. Okay, we don't typically express the slope as 4 divided by 1. We express it as 4. But when we go ahead and apply it on our graph, we apply it as this fraction here. So what is it? It's a rise of 4. Okay, and what is the sign? It's positive, means we're going up 4, 1, 2, 3, 4, and to the right 1. And that's why I've got that point here. That's the slope of 4. If the slope is 2, y is 2x plus 1. I go for my point here, I go up. Okay, I go up 1, 2, and I go over 1. And here is my point. Okay, if my slope, if I don't have a slope, where is the number in front of x here? It's just x. Okay, if it's just x, we recognize that is the same as 1 times x. Okay, we don't typically write 1 times x, we just write x. And then we recognize the slope of that, okay, is the same as 1 over 1. And that's how we apply the slope, okay? If there's a 1 in front of the x, which we don't typically write, we just leave it as x. So if it's x, it means a slope of 1, okay? The rise over run is 1 over 1. And that's what I apply here with y equals x plus 1. Plus 1 is my y-intercept. I go up 1 and to the right 1. And that gives me my line here. Now these lines would also go off that way. I didn't draw the left-hand side of the line just to not clutter my board so much and allow me to have this space to work on. Okay, but they do go off in this direction all the same as they do up here. Okay, I just didn't draw it for simplicity sake. Okay, and then what happens when we get a more familiar expression of slope here, 1/2. Again, the y-intercept is 1. I'm going to go up 1 unit, Okay, I have 1/2. That equals rise over run. That means the rise is 1, the run is 2. Okay, so from my y-intercept, I rise 1, and I go over 1, 2 units. Okay, it should be right here, is my point. And I draw my line in. Okay, here I have a slope of 1 over 4. Okay, that is now my rise over run. So my rise is 1 unit, and I go over 1, 2, 3, 4 units. Should be right here. 4 units. Okay. And my graph is a little off there, so I hope I don't have grid lines on my chalkboard here, so it's a little hard graphing at times. Okay, so that's how. So notice, with the same intercept, all of these have +1 as the y-intercept. Okay, the only thing different about them is the slope. And what do you notice about that? Well, when the number is bigger, like here, the biggest number in that set of slopes is 4. The line is really, really steep. Okay, when it's not so big, say right here where it's x, where it's actually just 1. Okay, the line is about in the middle. Okay, that line of y equals x plus 1 plots it like about this. That's y equals x plus 1. It's kind of steep, okay? It's about in the middle of being steep or not. And we notice if the slope here is less than 1, if it's a fraction, that means it's shallow. It is not steep at all. Okay, it's actually approaching flat. And in fact, as our slope gets smaller and smaller and smaller, it gets closer and closer and closer to a horizontal line. As our slope gets bigger and bigger and bigger, it gets closer and closer to a vertical line. Okay, so that's the big thing I want you to take away from this lesson. Okay, large numbers, large integers in the slope will be a really steep line. Okay, fractions in the slope will mean a gentle slope, a shallow line. Okay, generally anything, and by the way, this when the slope is 1, that equates to an angle of 45 degrees. Okay. This angle here is 45 degrees, okay? So if the slope is larger than 1, we say we have a steep slope. We're in this region of the graph, okay? The slope of the line's going to plot greater than 45 degrees. It's going to be a rather steep slope, okay? If the slope is less than 1, which is basically a fraction, if it's less than 1, it's going to be shallower. We'll be in this region of the graph, okay, where it's less than 45 degrees. And so that's something you can use to know. So when I see an equation like this, the slope is fractional. Okay, if I get a line and it's up here, and that's generally derived by plotting the line wrong, rise and run. Okay, I've switched them around. If my plot is really steep, I can sit back and look at that and go, boy, that should not be. This is a small number for the slope. The line should be shallow. It should be in this region of the graph. So you can use that as a double check. Okay, so those are the things I wanted to go over now. The same thing applies to negative slopes here. So we said our equation of the line here was y equals minus 2/3 x minus 2. We notice if this fraction here gets a little bit bigger, okay, let's double it. Okay, that would be 2 times 2/3 would be 4/3. Okay, so what would that mean? Okay, that would mean from here the line would drop, instead of minus 2/3, if it was twice as big, it would be minus 4/3. It would drop 1, 2, 3, 4, and then go over 1, 2, 3 to right here. Okay, that would mean a much steeper line, but it's in the negative slope region. It's a steeper line. It's approaching more vertical. Okay, this would be a slope of minus 4/3 x. This is a slope of minus 2/3 x. Okay, well, what if this number is a half? What if the slope is half of this line? Okay, 2/3 times 1/2 is 2/6, or it's 1/3. Okay, so the slope of the line would not be minus 2/3, it would be minus 1/3. Okay, that would mean down 1 and over 1, 2, 3 units. The slope of the line would now be here, minus 1/3 x. So we notice as the fraction gets smaller in the negative region, the line gets shallower and shallower and shallower, and it gets closer and closer and closer to a horizontal line. As this number gets bigger, okay, 4/3 is actually an improper fraction. Okay, we normally, in a proper form, would express this as minus 1 1/3. In the equation of the line, we do not do that. We leave it as an improper fraction so we can recognize it as a rise over run, as a slope. Okay, and as that number gets bigger and bigger and bigger in the negative region, that slope gets steeper and steeper and steeper, and it approaches a horizontal line, or excuse me, a vertical line, as that number gets bigger and bigger and bigger. Okay, so real quick, big numbers for slope means really steep lines. Small numbers, small fractions for slope means a gentle, flat sloping, shallow sloping line. Okay, so I hope that helps reiterating what's going on with the slope. That's the trickiest part of getting the equation of the line straight. So I hope that helps, and good luck with your review set today. So long for now.